Okay, continuing with the Mac 1105 Chapter 3 test, problem number 6. Okay, so in problem number 6, you're given f of x is equal to negative x squared minus 2x minus 8, and in this particular problem, you are being asked to find out whether it is a max or a minimum point. And when they ask you what the max or the minimum point is on a parabola, because these are both parabolas, being that the highest degree is second degree, you're really being asked for the vertex. Okay, now this is not vertex revealing form, so you're actually going to have to find it by formula. The vertex is at h and k. And when we do find that vertex, it's going to be a maximum point, and this is why. When the leading coefficient is negative, that means the parabola opens like this. Therefore, the vertex being at the high point is called a maximum. Then you have to know the formula for finding, and this is whenever the a value, that's the coefficient in front of x squared, is negative. Something being less than 0 means that it's negative. It means it opens this way, and therefore that vertex is called a maximum point. Actual formula for finding the h value is negative b over 2a. That'll get the front part. So it's opposite b over 2a. You're going to grab the b and the a value from the actual problem. This represents the b value. This represents the a value. Okay, so opposite of b. The b value is negative 2. A value is negative 1. So this turns out to be positive 2 over negative 2, which is negative 1. Okay, that's your h value. Now, if you want to find the k partner that goes with it, k, just like this, h is in the x position, k is in the y position, so k is synonymous to the y. We can find that by using this function. Y is equal to negative x squared minus 2x minus 8. Okay, and then this value that you have right here, I know it's the h, but again, it's in the x position, so you can use it as an x. So this will be positive 1, just from that part right there. Drop down the negative. Negative times negative is positive 2 minus 8. When you put these two together, you get positive 1. 1 take away 8 is negative 7. Okay, so y equal to negative 7 is the partner that goes with that. This y is actually the k value. Okay, so your vertex is negative 1 for the h, k value is negative 7, and again, it is a maximum point. Okay, likewise for this problem, leader is a negative, that a value is negative, and therefore it opens down. Therefore, the vertex that we're going to find is a maximum point. We're going to find it the same way, opposite of b over 2a. B value is negative 2. A value is negative 1. Again, this is 2 over negative 2. We get a negative 1 again. Plug this into the function to get the y value, which is really the k, because you're looking for h and k at the vertex. So y is negative x value minus 2 times the x value plus 2. And you're plugging this h value right in here. So this will be 1. That's for the squaring, but then you got to drop that extra negative down. You have a positive 2 in the middle and a positive 2 at the end. So we're going to get negative 1 plus 2 is 1. 1 plus 2, 3. So y is equal to 3. So the vertex is at negative 1, positive 3, and that vertex is a max. Okay, moving to problem number 8, which I have drawn for you here. And what they're asking for in that particular problem is they just want to know what kind of symmetry it has. This problem for number 8, you can do symmetry 2 different ways. There's an XY test that you can do, but you can also think about sort of spatial orientation, which is, I could explain with paper folding. When you have a graph that has origin symmetry, as this one has, you'll have the two pieces of the graph catty-corner to each other. You should be able to draw a line right through the origin. You're drawing the line called y equal to x. And on either side of that line, if you were to crease your paper right here and open it up, you would have mirror images. Another way to test this is that when a graph does have origin symmetry, if you can't, if you're not good at thinking about it spatially, as I just suggested with the paper folding, you can pick any point on one piece of the graph. Now I chose 1, 3 just because the numbers were easy to read. You should be able to find that same point, but with both of the signs switched on the other piece. And you can. When you switch this to -1, -3, if you look at the actual graph that I gave you on the practice test, this piece does run through -1, -3. That's another way. So for any point x, y on the graph, you should be able to find its -x, -y counterpart in the quadrant that's catty-corner to it. So this one has origin symmetry. Okay, for number 9, that one's pretty clear to see that if you were to crease the paper right here, that you have a matching image on either side. So this one has y-axis symmetry. If you want to do the XY test, for any point that you pick, let's say on the graph you had a point that was slightly past the 1. Let's say it was 1.2, and it was down at 1, 2, 3, -4. When it has y-axis symmetry, for any point that you pick on one side of the y-axis, you should be able to switch the x, but not the y, and find that point on the other side of the y-axis. And you can, right at about 1.2, but it was -1.2 this time because you're over here. You had that same y-coordinate. So whenever you can find the same point on both sides, where the x's have different signs but the y's have the same sign, that would be the XY test. For any point XY on the graph, you should be able to find this counterpart. Switch sign on the x, but don't switch the sign on the y. That also proves y-axis symmetry. Okay, then by the time we got to number 10, you're graphing. Now, the good thing about this one is that it's in factored form, because once they stop giving it to you in factored form, there is a lot more work to do. Sometimes they'll give you one where you can factor it. Sometimes you're going to, because the reason that the factors are good, if you have forgotten, is that they give you the x-intercepts, which is a very, very big part of the graph. Now, since this one is factored, we're already going to be able to find the x-intercepts very easily. When they don't give it to you like this, you can either sometimes factor it yourself, or sometimes you have to use the rational zero property in order to find the x-intercepts. Okay, so this one we're going to go with the factors. This factor gives the x-intercept x equal to +1, because these x-intercepts are also called the zeros. So when you give them, they are the numbers that make this factor 0. The number you could plug right in here and cause a 0 to happen would be the number 1. So that's the 0 that goes with that factor. Being that it comes from an expression that has a power of 1 right here, you are going to treat that as a through point. So in other words, once you go and plot it and you start trying to get the graph that goes with this, you're going to go right through this x-intercept rather than bounce off of it. as you're going to for this one that has an even power. That's whenever the power on the expression is odd, you're going to go through the point. This factor gives the x-intercept positive 3. It also has an odd power. So again, this is a through point. I'm going to go right through it. And again, the 3 is the thing that makes this 0. What makes this 0 is x equal to 0. However, this has an even power. The 0 goes right in there. It would cause this part of the expression to be 0. And when the power is even, that is what we call this is just one way to name it. It's a bounce point. You're going to like ricochet right off it when you approach that point. Okay, so we know what we're going to do at each of these x-intercepts, at 1, at 3, and at 0. We're going to bounce on this one, go through this one, go through this one. Now we also need to address what are the ends doing in this particular graph. So the ends of the graph, this is called the end behavior. What you want to do for that is you want to consider what is the very highest power that exists in this entire expression. And the way to address that is you got to ask yourself, what would this term be times this term times this term? You just consider the first term in each of the parentheses times the one that's out here. So that would be x squared times x to the first degree times x to the first degree. And consider multiplying them together as this suggests, the way they're all against each other. That means multiply them together and you would get x to the 2 plus 1 plus 1. When multiplying, you add up all the powers. Don't forget there's a negative there, because when you're doing the ends, it's all about the negativity of this leading coefficient as well as the power. You're looking at both of those things. So it is said that when the highest power in the problem is even, both of the ends go in the same direction. If there's a negative out front, they both go down. And if there's a positive out front, they both go up. So we're going to have the left end going down, the right end going down. What's happening at these x-intercepts will determine what this graph looks like in between the ends. But the left end goes down, the right end goes down. In addition to knowing the x-intercepts, what to do at the x-intercepts, and what the ends are doing, you're also going to need to know the y-intercept. So the y-intercept is when x is equal to 0. So get right in there, plug in a 0 everywhere there's an x, and figure out what y is. Okay, so it's y is equal to, put a 0 in there, square it, but then put the negative out there. And then put a 0 in there. Now you can probably already see what's going to happen if you're got your head on straight. You can see that when you multiply, just because this was a 0, this comes out to be a 0, because 0 squared is 0. You can't switch the sign on 0, so it remains 0. And at that point, it wouldn't matter what's in here. So if you weren't thinking about that, I'm just, showing you what it would turn out to be. If any one of these multipliers is 0, the whole thing comes out 0. So when x is 0, y is 0. That's a point that's going to be on the graph. Okay, putting all of this together, the information about the ends, the x-intercepts, what to do at the x-intercepts, bounce through and through, and the y-intercept, you get the graph. So here's the y-intercept. That's also this x value of 0. This serves a dual purpose here. And then you also have an x-intercept of 1 and an x-intercept of 3. Put your ends in place. On this end, you're going down. And on this end, you're going down. Okay, now start approaching the points. When you get to the 0, you're going to bounce. In other words, ricochet off of it. Don't go through it. So bounce right off of there, begin going down. Then in order to hit that point, you have to turn and go up. This time you're going to go through it. And then you're going to come down to catch this point and all the way down to connect to that end. Okay, and there's your graph. Okay, that's number 10. Okay, moving on to 11. Now, number 11 will not be presented in factored form, so we're going to have to go a little bit deeper with that problem. So problem number 11, let me get that copied. You have f of x is equal to x cubed minus 2x squared minus 5x plus 6. Okay, make sure I got all the signs here. Okay, so anyway, you can't factor this because the only way that you could start to factor would be factoring by grouping. And if you try to factor 2 at a time, which is factoring by grouping, you would take an x squared out, which would leave you with x minus 2, but then you can't take anything out of these two, so you can't continue with the factoring. Therefore, the back door would be to do the list of possible P over Q's. That was section 3, 4, and 3.5. And do synthetic division with them until you find the first 0, the first number that zeroes it out, because zeros are the same things as x-intercepts, which is what I got from the factored form in number 10, only it was factored. So here we're just going about it a different way. We're still looking for the x-intercepts. Okay, so let's make this list. If you don't recall, the p's come from down here. They are the factors of the constant. So these are going to be the numerators, just like this little formula says right here. The p's are on the top. Those are numerators. The denominators, the q's, which is what they're called, have to do with the leading coefficient, which luckily is a 1, and it can only be broken down as 1 times 1. So the bottoms are always going to be 1s, because these are the q's, and these will be the tops, one at a time. So it'll be 1 over 1, 2 over 1, 3 over 1, and 6 over 1. These are all the numbers that you can try as you begin to try and find the x-intercept. So I'm going to try the 1 first. I'll try the positive version, then the negative version. I might find it right away. Hopefully I will. Right now I'm trying positive 1. Take those coefficients and stretch them out going horizontally. Put a line under here, drop down the first one, 1 times 1, you multiply, bring the answer back up here, add, you get negative 1. 1 times negative 1 is negative 1, add these up, you get negative 6. 1 times negative 6 is negative 6, put this here, I've already found a 0. So when this zeroes out, you have actually found an x-intercept already. And that's not the x-intercept, nor is this. This is the x-intercept, the number that caused the zeroing out. So right at x equal to 1, you're going to have a point on your graph. Now, if you would like to write this in factored form, the factors will be expressions that include this number, but the opposite sign to this. So if this is an actual x-intercept, or a 0 as they're called, then this is what that number looks like, but in factored form. There'll be an x up here, and that number will have the opposite sign. So it looks like that is a factor, this as an actual x-intercept that you're going to place a point on. Now there's actually 3 factors because this is 3rd degree. So the other 2 are going to come from what I'm about to do right now. You have these numbers left over underneath the bar. Each one of these gets a letter. So if this started off as a 3rd degree function, you are now down to 2nd degree. This term is 1 degree less than this, and this is no degree. You can make a little equation out of this. 1 x squared minus x minus 6 by setting it equal to 0, and by factoring it, you're going to get the 2nd and the 3rd factor. And you're also going to get the next 2 x-intercepts. So let's see. The numbers to multiply to get 6, but to also get -1 would be -3 times +2. That times that is -6, but when you add them, you get -1. This factor gives an x-intercept of -2. Again, the factor will have one sign, the x-intercept will have the other sign. This gives the x-intercept 3. So those are your 3 x-intercepts. X equal to 1, x equal to -2, x equal to 3. Okay, and you can write them in factored form if you want. The only reason I think that this may help you understand what's happening is because we always look at the powers on these factors in order to know that whether they're bounce points or through points. Now you can see that you have 1 of each factor. That means the power on each of these factors is 1. Every time that power is odd on a factor, that means it is a through point. You're going to go right through it. Every single one of these factors has an odd point. So the x-intercept 1 that went with this, it came from this factor. This factor had an odd power. You're going to go right through the number 1. Likewise for x equal to -2 and for x equal to 3. These are all through points because every single one of them bared an odd power. Okay, once you know what to do at the x-intercepts, you have finished all of those, you're going to want to find what are the ends doing. What is the end behavior? So I'll just call it the ends. That has to do with the highest degree in the problem, which when it's not factored, you can tell it's the one up front. It's usually the one up front. So you want to look at the power as well as the leading coefficient. When the highest power is odd degree, the ends will go in opposite directions. One will go up, one will go down. Since this is a positive number, positive leading coefficient with an odd power, you go up on the right when that leading coefficient is positive, and then the other one has to go down because they have to go in opposite directions. Okay, up on the right when the leading coefficient of an odd power is positive. Okay, so we know what the ends are doing. Last thing you need to know is what is the y-intercept? Where do you hit the y-axis when you go to graph? So y-intercept, you're going to let x be equal to 0. And that's easy to do also because since this wasn't factored, the original function, when you plug in 0 here, it wipes out that term. So that's gone, wipes out that term and that term. So the only number that's left standing is the 6. So you'll have, since these are all gone, by plugging in a 0 is the reason they're gone, you'll have y is equal to 6. So y is equal to 6 when x is equal to 0. Put all of this together and you have the graph. Okay, the graph is, just put all of this right onto your graph. Go to x equal to 1. Put a point. Go x equal to -2. Put another point. Go to x equal to 3. Put another point. Okay, now put the ends in place. Rightmost end goes up. Leftmost end goes down. Okay, now head for the points. Don't forget to put the y-intercept. That's this right here. Y hits at 6. Better put that in first. 2, 3, 4, 5, 6. Your graph is also going to hit there. So you got to connect all these dots and make them connect to the ends as well. Okay, we're going through everything single point. So we're going through this one. Have to hit that y-intercept. Have to hit the 1, but go through it. Have to hit the 3 and go through it, and have to end up connecting to that end. So this is a graph. Okay, next is number 12, which is just like this. And in number 12, you have f of x is equal to x cubed plus 2x squared minus 5x minus 6. Okay, so let's start again. Again, you cannot factor this, so we're going to have to go at it using the P over Q list. Okay, again, the factors of this are 6 times 1, 3 times 2. These are going to be the P's, in other words, the tops. This factored down would be 1 times 1. These factors right here make up the bottom, so your bottoms are 1. Throw that plus or minus so that you know you can use either positive or negative versions of the numbers that are in this list. So it's 1 over 1, 2 over 1, 3 over 1, and 6 over 1. You have this same list, and you're just going to begin trying the numbers. You're only allowed to try the numbers from the list. I'll start with positive 1. If that doesn't work, I'll use negative 1, and I'll go through the list until I find the first 0. Take the numbers, the coefficients, stretch them out. 1, 2, negative 5, negative 6. Drop down that first number. 1 times 1 is 1. Add these up, you get 3. 1 times 3 is 3. Add these up, you get negative 2. 1 times negative 2 is negative 2. Add these up, you get negative 8. So that didn't work. Move on to try negative 1. Try the negative version as well. Again, stretch the numbers out. 1, 2, negative 5, negative 6. 1, 2, negative 5, negative 6. Drop that first number down. Negative 1 times 1, negative 1. Add these up, you get a 1. Negative 1 times 1 is negative 1. Add these up, you get a negative 6. Negative 1 times negative 6 is 6. Add these up, you get a 0. Okay, so I have zeroed out. That means I have found an x-intercept. And if you want to write the problem in factored form, because it was not in factored form when you started, the very first x-intercept is x equal to negative 1. So that's one of your x-intercepts. It would look like this in factored form. It would present as an x positive 1. The other two factors are going to come from right here. I'm about to factor this. This would be x squared. This would be x. This would be negative 6. That blank spot, you can put a plus sign. Maybe bring it down here. Make an equation. Get the other two factors, which will give us the other two x-intercepts. This is an x-intercept. This is the factor that goes with that x-intercept. So this factors as x times x is x squared. We want to multiply to get negative 6, so it's definitely a 3 and a 2, but we need a positive 1 to occur off of that 3 and 2. So it should be positive 3, but a negative 2. So that times that is negative 6, but when you add them, you get positive 1, which is in the middle. Okay, so the x-intercepts you get from this are positive 2 and negative 3. Okay, if you want to write them in factored form, an x-intercept of positive 2 would look like this in factored form. An x-intercept of negative 3 would look like this in factored form. You see they all have power of 1. So everybody's power is odd, therefore they're all through points. You're going to go right through them when you graph them. Okay, what are the ends doing? Well, the highest degree is third degree, and it's got a positive 1 in front of it. And you don't even have to write the number, you just need to know the sign. So odd degree, you have opposing directions on your ends. And since it's positive, the right side goes up. And since they go in different directions, the left side therefore has to go down. So this is what the ends are doing. And then the y-intercept. Y-intercept is when you let x be 0, and you can get this very easily without doing any work. There's the y, that f of x. If you let x be 0 here, here, and here, that wipes out the first 3 terms and leaves you with just negative 6. Okay, you're going to put all of this together in a graph. Okay, so my x-intercepts are negative 1, 2, and negative 3. Okay, so you're going to put 1 at negative 3, you're going to put 1 at 2, and you're going to put 1 at negative 1. We're going to hit all those points. The ends are going to go up on the right, down on the left. Then you're going to put a y-intercept of negative 6, 2, 3, 4, 5, 6. Right there. And you're going to hit all these points. Just connect the dots now. You're going through each of the x-intercepts as well as the y-intercept. You're going to go through, turn to go through negative 1, go through that y-intercept up to catch the 2 and right to that end. And that's the picture for number 12. That completes all the way up through 12. Okay, starting with number 13, Mac 1105, Chapter 3, Practice Test. Okay, so in number 13, you're given x cubed plus 2x squared minus 9x plus 18. You're asked to find the rational zeros. So you're going to need to make the list of rational possibilities. Okay, the p's, the tops, the numerators, they come from here. They're any of the factors of this constant. So it could be 6 or 3, it could be 9 or 2 as the numerator, or even 1 or 18. So any of these numbers can make up the tops of the fractions, the numerators, and then this coefficient says, which only factors as 1 times 1, these are the Q values, or in other words, the denominators. Okay, so the fractions are 1 over 1, 2 over 1, 3 over 1, 6 over 1, 9 over 1, and 18 over 1. Okay, so I've tried each of these as the tops, using those always as the bottoms. Okay, so I'm going to just start trying them. This is the first one I'm trying is 1. Take these numbers, stretch them out, the coefficients going across. 2, negative 9, negative 18. Put this number underneath, put the 1 down here. Drop the first number and it's 1 times 1. Carry that answer here, you get a 3. Then 1 times 3 is 3. Bring this down, you get a negative 6, and then negative 6 that you did not end up getting a 0, so try the next value, which is going to be that same number with the negative. Take the numbers, go across again, 1, 2, negative 9, negative 18. Drop the first number down as is, negative 1 times 1, negative 1. Get a 1. Negative 1 times 1, negative 1, you get a negative 10. Negative 1 times negative 10, you get a 10. Add these up, you get negative 8. That one also didn't work. Now trying 2. So it's 1, 2, negative 9, and negative 18. I'm trying the 2. Drop the first number down, you get a 1. 1 times 2 is 2. Get a 2. Add these up, you get a 4. 2 times 4 is 8. Add these up, you get a negative 1. 2 times negative 1, you get a negative 2. I did not zero out, so that one doesn't work, that one doesn't work, that doesn't work. I'm going to try negative 2 now. Again, stretch those numbers out. Negative 9, negative 18. Put the bar underneath, drop the first one down. Negative 2 times 1, negative 2. Add them up, you get 0. This times this is 0. Add these up, you get negative 9. Negative 2 times negative, and there we go. There's my first 0. Yay. Okay, so once you find that first 0, you can start keeping a list of the answers. This is one of the answers. You can get the other 2 right here without going through this anymore. Just put the letters back on there. It was third degree, now it's second degree. There is no first degree term, this is the constant. So what you're seeing here is x squared minus 9. You're going to make an equation out of it. You're going to get the other two zeros, the other two solutions as they're called. Okay, just factor to get them. So then you don't have to go through this again. That's just to find the first one when it's third degree anyway. Okay, so to factor this, it's take the square root of the front, x and x, take the square root of the back, which is -3, and +3. These factors present x equal to -3 as the solution and x equal to +3. So those are your other two answers, -3 and +3. All three answers. Okay, going to number 14. In problem number 14, you have a rational function for x on the top, and you have x squared minus 36 on the bottom, which I'm going to factor so I can talk about the asymptotes. Okay, the vertical asymptotes come from the bottom, but you got to factor to reveal them. So we're going to x there and an x there. This factors into -6 plus 6. This factor gives a vertical asymptote of -6. And x can't be -6, therefore there's a vertical asymptote. This gives a vertical asymptote. X can't be 6. So you're going to come now, start the graph off with the vertical asymptotes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And you can put your vertical asymptotes in there. Okay, then the horizontal asymptote, when the power on the top is less than the power in the bottom. Okay, numerator degree is less than the denominator degree. That means y equal to 0 is the horizontal asymptote. Okay, this is whenever the degree on the numerator is less than the degree on the bottom. So this is going to be our horizontal asymptote. Horizontal asymptote, the x-axis is called y equal to 0. This is one of the vertical asymptotes. This is one of the vertical asymptotes. This is called x equal to 6. This one's called x equal to -6. I want you to be able to answer, name those asymptotes with letters. When it's a line that goes horizontally, it's called y is equal to, and then the number that it shoots through on the y-axis. So here's your y-axis. There's 0. It shoots right through 0. So this horizontal line's called y equal to 0. This is a vertical asymptote. It shoots through the x value 6, so it's called x is equal to 6. This shoots through x value -6, and so that's the name of it. Now you're going to have to figure out the shapes that exist on the right, in the middle, and on the left. So as you go to look at this graph, you can use your calculator if you want to actually get the shapes, but I want you to at least develop it this far. Tell me what the horizontal asymptote is. Tell me what the vertical asymptotes are. If you are going to try and do it by hand, it can also be done by hand. It's not that hard. You would just pick an x value over here and just see if it comes out positive or negative. When you go and plug in like something like 7 directly to the right of the 6. You go and plug it in there and there, and you can get second table to do it. That's why I'm letting you use your calculator, because even that you could get on the calculator. So if you were to press this into the calculator, you would just go to y is equal to, get rid of what's there. The top only has one term in it, so you don't have to put it in parentheses. It's just 4x divided by, and then the denominator does need to put in parentheses because there's more than one term. It'd be x squared minus 36. And then if you graph it, you see the shape that's in the middle, and the shapes, okay, you got two hyperbolic wings. one above the x-axis on the right, the other one below, and then in the middle you can see the shape there. Okay, so you can just paste those right into place. Find them yourselves if you want. I'm going to plug in the values, make it go right through there. Okay, so that's the graph for number 14. Moving on to 15. So on problem number 15, guess I'll do it right here on the actual test. Let's see. This looks like almost the same one that we just had. The bottom is just x minus 4, x plus 4, so it's just like it, 4x on the top. Okay, so you have a vertical asymptote at x equal to 4. X is not allowed to be equal to 4 or it would create a 0 here. X is not allowed to be equal to negative 4 or it would create a 0 there. So put asymptotes at those numbers. So there's one right here and there's one right here. Okay, then the power on the top is less than the power on the bottom, so this is going to be your horizontal asymptote. The x-axis is also called y equal to 0. This is a vertical asymptote. This is a vertical asymptote. And this one's called x equal to 4. This one's called x equal to negative 4. And then you can get the shape from the calculator. You can just go right in there. It's going to be the same shape though. So 4x divided by, bottom has to be in parentheses because it's got two terms. Okay, so it's x squared minus 16. Close that up, accept it, graph. Okay, same shape. Okay, so you have a wing that you're pasting there, held up by the horizontal asymptote. You have this S shape that's in the middle that goes right through the 0, and then you have a wing right there, catty corner to that wing. So that's the answer for that one. This one, let's see, the bottom factors in 2. X minus 5, x plus 5 over 2x squared. So the vertical asymptotes are at positive 5 and negative 5. Okay, again, you have 3 sections. This time, the power on the top matches the power on the bottom, so the horizontal asymptote is made out of a fraction. Horizontal asymptotes are equations that start with y. Going to make up this fraction. It's a top number, top coefficient over the bottom coefficient. These leading coefficients right here. That's how you get the horizontal asymptote. So, excuse me, at y equal to 2, which is right there. That's your horizontal asymptote. Okay, you can go to your calculator, feed in the actual function, which was 2x squared on the top, divided by, and then your bottom was x squared minus 25. X squared minus 25. Okay. Okay, so this time we have both wings at the top, parabola in the bottom. Skim it right up against the asymptotes. So it goes right up against that horizontal asymptote. Actually doesn't paste to it, it just stays slightly away, and then we have one wing here and one wing here. Okay, last two problems. You're solving an inequality, and we're going to use the cut point method. Okay, that takes factoring the polynomial that you see right here, treating it temporarily as an equation to get the cut points. You're really trying to get the intercepts on this line, so or the zeros on this line. So when you go to factor this, it's x and x, and then you need two numbers that multiply to give you 12, but combine to give you 8. So that would be 6 and 2. 6 times 2, when this is positive, these are both the same. This is what they both are when you go to factor. Okay, so this gives a cut point of x equal to positive. Remember, what they look like in factored form, they're the opposite as a 0. And then this one gives an x value or a 0 of 6. Okay, so you're going to put a dot on 2, dot on 6. Okay, and then what you're going to do is you're going to test the intervals that are to the left of this point, in between the points, and to the right of the point. Notice that it's a greater than symbol but without an equal sign. So all you have to do is pick a number, and you can actually pick any of these regions. They're going to alternate with respect to what regions work and what regions don't work. So if you, let's say you like to test the number 0, just because it's so easy to plug in. Just locate where it's at. Here it is right here. So you're testing this region right here. Might want to put a note that you're testing 0. Okay, then when you test it, it just means you're plugging it right in the inequality. That would wipe, it would get rid of this when you plug it in. Now I'll actually show the work, but really you don't need to. If you're plugging in a 0 and it makes that term go away, you don't even need to write that term. So this would be gone, this would be gone. You'd have 12 greater than 0. That is true. So yes, everything in here works. This would be no, everything in here doesn't work. This would be yes, everything in here does work. Okay, when you go to give your final answer for these problems, you talk about the regions that have a yes, because everything in those regions work. So you're going to come all the way out from negative infinity all the way into this value. You're going to have a parenthesis there because this has no little equal sign, so it can't be a bracket. So everything from negative infinity all the way up to, but not including that positive 2 value. Then you want to skip over the area that has the no on it. Skip over using the union symbol, and then everything from 6 to out here where this yes region is, that's positive infinity. So 6 to positive infinity, that's the answer for 17. Finally, 18. Okay, same thing, you're going to start by factoring that, treating it as an equation that factors into, let's see, we need a 7 and we need an 8, so 7 times 1. This would give you negative 7. This would give you negative 1. You're going to choose a tester value. Again, I like the 0, so I'm going to test this right here. I've chosen the 0 from this interval over here. And I'm going to plug it right into the equation. It would get rid of this, leave you with just a 7, and you just have to decide, is that true or false? Yes, this is true. So everything in this region is a yes. That all works. Therefore, this would be a no, and everything out here would be a yes. So it's just like number 17, everything in this region out here, up to, but not including the negative 7 works. Okay, so everything from negative infinity up to, but not including the negative 7, Close that off. Skip over the part where it says no by saying or. That means or you can also find answers in this yes region, which goes all the way from -1 to positive infinity. And this one went all the way from -7 to negative infinity. So this is -1 to positive infinity. Okay, and that's 18. Anything in this region works. Anything in this region works. That's when you as values that you can plug in and get a true statement. Likewise here. Okay, that completes the review for Chapter 3. Make sure there's no more problems before I sign off. Yep, I think that does it. Okay, so good luck studying for the test. You can meet me on the discussion board if you have any further questions.